Hello, everyone, and welcome back. Where today we're going to be talking about the Performance Task Explorer. This will carry us through the rest of the semester. It's the only thing you got left to work on, and let's dive right into it. You can ask me some questions as we go. So, the AP Computer Science Principle course has three assessments, or had three assessments consisting of two performance tasks and an end of course AP exam. So, there's a link here to where I'm pulling this from via the College Board. This is what the traditional breakdown was supposed to be. The end of course exam constituted 60% of your AP score, whereas the performance task and create performance task, the explore and create performance task kind of summed up the other 40%. Now, due to COVID-19, there just simply won't be an AP exam for this year, right? That means your AP score is completely coming from these performance tasks. Now, I have not seen a breakdown on how that score is going to be. I'm not sure if it exists. Maybe I just missed it. But what I am kind of expecting due to the breakdown here is that the explore task will be somewhere between 30 to 40%, and the create task will make up the rest between 60 to 70% of your AP score would come from those two things. So your score is going to be coming from those performance tasks, and additionally, they pushed the due date a little bit later. Thank you. Said it in chat. Create is 60%, Explore is 40%. Can you shoot me a link on where you found that? So the due date got pushed a little bit to May 26th. Again, there's a link here in the slides to where I'm pulling that information from. Why don't we visit this? So this is kind of a one-stop shop for all the stuff related to the assessment, in this case, these performance tasks. Again, we see the due date has been pushed. You have to basically upload that online through the digital portfolio. I will either create a video or find a video kind of demonstrating that on how to upload to the digital portfolio. Now, it's a little bit hard for me because I'm a teacher, not a student, and you ultimately need to see it from the student perspective. Okay, let's jump back to our slides. So, let's talk about Explore. Effectively, these are your steps to completing Explore. You're going to select a computing innovation. We'll talk about what that is. You're going to conduct research and document sources. You're going to create a computational artifact. We'll talk about what that is. And then you're going to, just like with the create task, respond to some prompts. Now, there's a link here. It'll tell you where I found all this stuff. And this is on page 4 of this description is where I'm effectively pulling this from. So select a computing innovation. Okay, a computing innovation, kind of missing a slide. It's computing innovation is any type of innovation that uses a computer or program code as an integral part of its functions. Physical examples of computing innovations are things like your cell phone or smart devices such as a smart speaker, maybe a smart watch. A computing innovation could also be some type of application, maybe a piece of software. Examples of this include open broadcast software, which I'm using to record this, maybe some type of photo editing software like Photoshop, maybe Discord or Microsoft Teams, some type of communication software. They could be web-based services such as Google Slides, which I'm on now, that sort of thing. Or they could be theoretical, something like e-commerce. I feel like maybe autonomous vehicles kind of falls in this theoretical example. We're going to take a look at some examples later on, and one of them for sure is theoretical. So those are examples of computing innovations. Again, they have to use a computer or program code as an integral part of their functionality. One thing you want to do when you're choosing a computing information is keep writing prompts 2C and 2D in mind. Okay, so let's kind of jump ahead and talk about what 2C and 2D are. 2C says, this is one of your writing prompts, explain at least one beneficial effect and at least one harmful effect the computing innovation has had or has the potential to have on society, economy, or culture. Now, You got to be able to do both, right? You got to be able to name one beneficial effect and one harmful effect. Maybe you're talking about social media. Maybe you're talking specifically about something like Instagram, and so beneficial effects include the ability for people to kind of share and communicate through social media. A harmful effect may be something like the psychological repercussions of social media. What does it do to people, right? And so that kind of encompasses these sorts of things, right? Beneficial effect of Amazon.com is that people can readily get a hold of things that they need. A harmful effect to maybe the economy is that they undercut prices, and so brick and mortar retailers start to go out of business. Those are examples. Now, the reason why we're talking about it now when we're talking about selecting a computing innovation is if you can't answer this when you're selecting a computing innovation, then you probably want to select something else. That's all. 2D is saying using specific details to describe the data your innovation uses. Okay, in the case of a smart speaker, it's using audio, right? I'm talking to the smart speaker in order to feed it data. In the case of autonomous vehicles, right now, a lot of them are using cameras and light sensors. That is the data that it is taking in. You have to talk about how the innovation consumes that input, right? And a smart speaker is using a microphone in order to take in that audio input, and it's using the actual speaker to produce output, right? It could also maybe transform the data. At least one data storage concern. This is all still part of 2D. Okay, in the case of your smart speaker, right, there's data storage concern, data privacy concern, and data security concern. So your smart speaker kind of falls under all of these things. A data storage concern is that maybe the data that it takes in, audio, is being stored, and that ends up you need basically server space in order to store all of that audio. Right? Audio is not, it's a relatively large file type, right? Text is incredibly small, video is incredibly large, audio is somewhere in between. But if you're taking in a lot of audio or a lot of video, a lot of data, you need to store it somewhere, you're going to need basically servers to store that. So that is a storage concern. Now, it falls into the privacy or security concern is, what if someone hacks into those servers and gets a hold of the audio? Is that a problem? Okay. So those are 2C and 2D. You want to keep those in mind whenever you're trying to select a computing innovation, because if you can't answer 2C and 2D, then you need to pick something else. Once you have selected a computing innovation, you'll conduct research, and this kind of falls under 2E, again, a written response, where you're going to need to cite your resources that you're pulling these through. You need at least three online or print resources. So you can cite a website, or you can use something like a magazine, a newspaper, that sort of thing. At least two of the sources, 2 out of 3, must have been created after the end of the previous academic year. So you need to use relatively up-to-date resources. For each online source, we'll cover up some text here. Let's slide off camera, question mark. Whee! For each online source, include the complete and permanent URL. Where are you grabbing this from? Identify the author, title, source, the data you retrieved, the source, the date. Sorry, I think that should be date. That should be date that you retrieved the source. The date you retrieved the source, and if possible, the date the reference was written or posted. For each print source, include the author, title, excerpt, article, magazine, book, page numbers, publishers, etc. I imagine, so for most people, they use online resources and call it a day. Now, that being said, if you have a resource and you can't find this information, author, title, that sort of thing, I recommend finding another source. Right. Every year I get students just like, well, I don't like. I've got a good source. It doesn't have like an author listed. Right. It's just an article on a website. Chances are your computing innovation has tons of information about it, so you can find something that has an author title, etc. I recommend looking for resources, making sure that you have these things. It is possible to do an interview. You can do an in-person interview, and I can actually think of a few students where this could be the case. Maybe you have a parental figure, or a person that works at some type of tech company, and you can actually interview the person in particular. You can use that as a source. Now, this is going to be a big one. You have to cite stuff in your written responses. Like, it's one thing to basically research this and then list it as a source. You also need to include in-text citations for whenever you are spitting out some type of fact about your computing innovation. You got to cite it. And then, of course, each source must be relevant, credible, and easily accessed. So once you have picked a computing information and innovation, you've done your research, you want to create a computational artifact. And all this means is something produced by a computer. Okay, video, audio, and what most people are going to go with is some type of PDF. Generally, what I see, and probably the easiest route, is to create essentially a one-page flyer about your computing innovation. This is what I recommend. This is what I want you to think about, right? I'm going to create a one-page flyer on autonomous vehicles. I'm going to create a one-page flyer on smart speakers, right? It's something that you kind of want to stick on the wall that'll explain to people that don't quite know what autonomous vehicles are, or don't quite know what smart speakers are. Once you've created your computational artifact, there's a few more writing prompts that are directly related to the computational artifact, such as 2A. You'll provide information about your computing innovation and computational artifact. You'll name it, as well as the computational artifact. You'll describe the computing innovation's intended purpose and function. The purpose of smart speakers are to listen to users and provide answers to questions or prompts via audio. The purpose of autonomous vehicles is to drive vehicles so that humans don't have to, using artificial intelligence. Describe how your computational artifact illustrates, represents, or explains the computing innovation's intended purpose, its function, or its effect. So you're talking about how your artifact, the thing that you made, that video, audio, or PDF, like a one-page flyer, you're talking about that and how it illustrates, represents, or explains your computing innovation's intended purpose. 2B, describe your development process, explicitly identifying the computing tools and techniques you use to create your artifact. Now, this is pertaining to your artifact, right? If I am making a video, I'm likely using video editing software. That's what this is talking about. What software did you use? If you're making a one-page flyer, maybe you're doing that in something like Microsoft Word, some type of text editing tool. Maybe you used Photoshop, maybe you used MS Paint in order to edit your photos. So you're using software to help develop your artifact. That's what you're talking about here. Your description must be detailed enough so that a person unfamiliar with those tools and techniques will understand your process. So in describing what you used, you can't just list it. You kind of got to, give a description of how it is used, right? In Microsoft Word, for instance, maybe I imported some images and then laid text on top of them. Maybe there's some tools that you use to edit the margins so that maybe the flyer goes completely edge to edge. And that's the kind of stuff I would maybe explain. Now, these written responses do have word counts, right? 2A, which is dealing with just naming your computational artifact. is 100 words. 2B, which is describing the tools you used to develop your artifact, again 100. 2C and 2D, we're talking about the computing innovation itself, its intended purpose, beneficial and harmful effects. 2D is talking about the data that it used. You see the limit count there. 2E is not listed because that is merely your resources, so there is no word count there. Now, here are just a bunch of links for resources. Right, we have the actual description, which I brought up before, and it is pretty detailed. I invite you to go through and read it because I basically just covered an overview of it. There are the written responses template, which is where you can go in and just kind of directly plug in your responses to the prompts. There are the scoring guidelines, which again, I'm not going to go super in depth on these, but I invite you to take a look at these. What I really want to get to are the examples, because I think that's going to be the best indicator of what in the world is going on. So there's this website. Again, it is linked in the slides. Maybe I'll throw it in the YouTube video description. But about midway down, we got scoring guidelines and notes for the 2019 exam administration. So there are explore examples, there are create. We've seen this one before, but let's click on the first one. And I can go ahead and tell you that this first artifact and written responses it's a perfect score across the board, right? There are 7 categories. If we look at our scoring guidelines, we got, that's for create. Here's explore. We got 1, 2, 3, 4, 5, 6, 7, 8. Sorry, there are 8 rows for scoring the explore performance task. And the first example that we're going to look at had a perfect score. And generally that's how they list these out, right? The stuff towards the top are really good examples of what to do, and the stuff towards the bottom are really good examples of what not to do. So looking at this first computational artifact, it is on facial recognition software. I would kind of classify this as a theoretical computing innovation, right? But we see images, we see some text kind of describing what's going on, and there's not a lot going on here, right? Like, this is just a one-page PDF, some images, some text, and that's plenty fine for a computational artifact. If we go and take a look at the written responses, right? Here we see there's 2A. We'll see their response. The computing innovation represented by my computational artifact is facial recognition software. This software functions by detecting a face in an image or video that is matched with known faces in a database for identification. Here is the inline text citation, right? So they end up, this is going to correspond with 1 down in 2E. Just take my word for it. This purpose to then identify individuals in the image or video which may be used for security measures in catching crime. My computational artifact describes how facial recognition software captures images, identifies faces with these images, and compares these faces with individuals to serve the purpose of identification. Reading comprehension is hard, reading is hard, especially when there's some typos in it. So what I'm going to now do is I'm going to copy that bad boy for now. But we see the artifact there. You then want to maybe cross-reference it with the commentary. So I'm going to pull up the written responses on one side. I'm going to pull up the commentary on the other side. And what we're going to do is kind of cross-reference these things. So there's the scoring guidelines, and this is the actual response, right, that the score gave for this. Row 1, which is pertaining to 2A, the response earned the point for this row. The computing innovation is identified as facial recognition software. Boom, we did that. We gave a name to it. We talked about it here. The computational artifact uses the image of facial recognition software in an arrow to point to the metrics that are being captured by the computing innovation to demonstrate its function. It looks like this image was just one that the student got from online, but the arrows and the text, this is stuff that they overlaid inside of their editor to help make their computational artifact. Okay. Row 2, the response earned a point for this row. The response states a function about the correctly identified computing innovation functions by detecting a face in an image or video that is matched with known faces in a database for identification. Okay, I believe row 3, let's go back up to our scoring guidelines so I kind of know where we're supposed to be at in our written responses. Row 3 is in regards to response 2C, right? 2C, if you recall, was where we're talking about the harmful or beneficial effects. So why don't we jump down to 2C and see what the student said about their computational artifact. One beneficial effect facial recognition software has on society is lowering crime rates. The photographs of known shoplifters are matched to a criminal database, then retail loss prevention and security are notified to prevent further crime, causing rates to decrease. Again, here is a inline text citation. Don't forget those. One harmful effect facial recognition software has the potential to have on society is its misidentifying tendencies, more often misidentifying people of color. This misidentification can lead to extreme consequences as this device is used by law enforcement and could incriminate the wrong person. Great. So we see a beneficial effect, we see a harmful effect. And I like the sentence stem here. I mean, the student was very direct. One beneficial effect, one harmful effect. You're making it very clear to the reader, and you kind of want to do that. You want to make their job easy because it makes it easy to identify these things and easy for them to award you a point. Okay, the response earned a point for this row. It states a beneficial effect, lower crime rate. I would also add here we listed a harmful effect. Okay, row 4, which it corresponds with, again, to C. Maybe that's where we're talking about the harmful effect. Response earned a point for this row, identifies a beneficial effect as lowering the crime rate. The response identifies a harmful effect as blah, 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 blah. Row 5, which is dealing with still a response to C. The response earned a point for this row. The response explains how the harmful effect relates to the society, its misidentifying tendencies, blah, 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 blah. It looks like we're talking about, listing them and then kind of describing them. Row 6 starts to get into 2D. Let's look at what the student had to say. The data that facial recognition software consumes are pictures and videos through cameras. Capturing their images first, the software identifies the part of the image that represents the face. Secondly, the image is transformed into a format that allows all images to have the same resolution, focus, brightness, etc. Thirdly, facial features are extracted from the image, so the software can now focus on only the most important bits of data. Now, object classification begins where the software matches facial features to individuals. One, data privacy concern. So there we're just talking about what kind of data does it take in. And then there's a bit, even using the word transform. I like that. I like seeing that because if you recall, 2D, they want us to talk about how data is transformed. Again, making it very easy for the reader. One data privacy concern is that humans will be tracked by simply going out in public. This is an invasion of privacy and would be prohibited by the U.S. Supreme Court under blah, 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 blah. A person does not surrender blah, blah, blah. With facial recognition, this privacy is not protected because people are being tracked by their face when they go into public. And some of you may recall some of the Hong Kong protests. They were very worried about this very same thing, and they were wearing masks while protesting. So row 6 and 7 are going to deal with response 2D. The response earned a point for this row. Cites data. The response cites the data as pictures and videos, so we're talking about the data that we're capturing. The response explains that the data is transformed to a format that allows all images to have the same resolution, focus, brightness, etc. So it is taking in the data, it is transforming it, basically structuring the data so that it is similar whenever we go to analyze it. Row 7, the response earned a point for this row. The response states that a privacy concern, one data privacy concern is that humans will be tracked. Okay. Lastly, row 8, at least 3 in-text attributed citations are being used and the corresponding bibliography is included. So 2E, we see our references. They have a corresponding number from where they were cited in line. That was a good example. Okay, let's go back and let's look at an example, maybe not so great. Here is our artifact, the Intel i9 processor. Okay. Got that one? You got it in mind? Let's pull up our written responses. And let us jump to the Explore commentary where they talked about J. You see, J earned only 2 out of 8 points, or they got 25% of this Explore task correct. I'm going to zoom in a little bit more. Okay. Now, row 1 is talking about 2A, that is identifying the computing innovation in computational artifact. The computing innovation was identified in the written response as the Intel Core 9. Right, here we see the Intel Core 9 Extreme Edition is one of the best processors on the market. The purpose of the processor is to read instructions given by a computing program. The i9 is an elite processor that has 18 cores and hyperthreading. It was declared by Intel as the best gaming CPU in the world. This processor has broken barriers in taking computer processing to a level one could only imagine. The artifact I created shows the processor in a bit of binary code. Binary code can be used as instructions that is read by a processor. It also has different models of the i9 processor. So we identified the i9 processor and kind of talked about how it is used to read instructions. Okay, 2D starts talking about the actual computational artifact. Let's read what they said in 2B. Sorry, row 2. When creating my artifact, I decided that I wanted to have an illustration of a processor in a computer, so one would know what it would look like. I also wanted to find the model of a processor I was doing, so I looked up pictures of the specific model. Reading from different articles, I found an interesting feature of the i9 processor, such as the 18 cores, hyperthreading, and turbo boost technology, so I put that in my artifact as well. We earned a point for this. I don't quite... Oh, sorry. Row 2 is still talking about 2A. The response, the purpose of blah, blah, blah. It talks about the computing innovation's purpose. Row 3 is where we start to get into 2B. Now, they did not earn a point here, and you should be able to see why. They talked about... they do not state the effect of the computing innovation, and it only spits out facts. We don't kind of talk about what... the development process was like. What type of software did you use to make this illustration? It was never kind of listed. Okay, they talked about essentially Googling images and articles, and that was about it. Let's take a look at 2C. One of the biggest benefits of this new technology is that this is the next step, the next level of gaming and other functions of computers. Having 18 cores is something that is very new and can be very beneficial to computing processing. Unfortunately, not everyone can get their hands on this latest technology because of the price. Models of the i9 vary, but usually it is around $500. Keep in mind what you should be talking about in 2C is the beneficial and harmful effects of the computing innovation. The response did not earn a point. The response does not identify a beneficial effect of the computing innovation. That it is the next level of the gaming and other functions of computers and has 18 cores are facts about innovation, not effects. The response does not identify a harmful effect at all, and not everyone can get one is not really a direct effect. Okay, I don't know if you could really name a harmful effect of a new processor, without going into something like maybe environmental or economic impacts. Like, what does this processor, how does it impact the economy? How does it impact the environment? Maybe they're using a kind of a rare metal or something that's not readily in supply, and that has an impact. And that's kind of what you can talk about the downsides are. Row 5, this should still be dealing with 2C. The response did not earn a point for this row. The response does not explain innovation, how the innovation relates to society, economy, or culture. No effects are identified. Maybe if we would have expanded on this $500 price tag, we could have gone into how it affects the society or economy. Okay, let's read 2D. The i9 processor, and all processors in general, will access data and memory from the RAM and then use it to carry out instructions. It reads the instructions in binary, and as a result, the processor is able to run games and other applications. Unfortunately, not all of the current i9 models and 18 cores and has the power to run an almost excessive amount of applications for your device. The first i9 processor model that was released only had 8 cores, which is fine, but it doesn't break the next barrier of technology. The model with 18 cores is obviously more expensive, and people might not want to get that extreme for a higher price. 2D is supposed to be talking about the data that it takes in, how it transforms it. We may be getting pretty close there, but then it needs to address data concerns, maybe storing the data, maybe security concerns, that sort of thing. So let's look at row 6, which corresponds with 2D. We did not earn our point. The response does not identify data used by the innovation. It states that it will access data and memory from RAM, but does not describe what specific data is being used. And we kind of talk about stuff in binary. This is hard. Like I wouldn't choose this innovation to begin with. This is when we're going back to selecting a computing innovation. This is not what I would choose because it's hard to talk about 2C and 2D. And we see that kind of manifest itself. The reference to reads the instructions in binary does not identify the data because binary numbers make up data and are not a specific type of data. All right, row 7, we did not get a point here. The response does not identify any data storage, privacy, or security concerns. That one's just flat out true. It just never even addressed it. Row 8, again, is dealing with 2E. We do not have any inline citation to support our references. You look back over it and you quickly see, yeah, there are references here, but you see that it does not matter. Basically, all of that research done just goes out the window. Despite it being here, the student did not cite anything inline, and you immediately lose the point for the entire row. You see why that's a big deal. Okay, so we've seen examples of what to do and what not to do. I highly recommend you check out the other ones. I highly recommend you look over the scoring guidelines. Some teachers even kind of recommend trying to look at an artifact in a written response using an empty rubric and score it yourself. Then go cross-reference the Explore commentary to see how close did you get in order to score that. So you're going to need to basically create a artifact. Again, most students end up doing something like a flyer, a one-page PDF. You are going to have to respond to the written responses, and those things will get uploaded eventually to the College Board. Also, yes, we'll take it on Canvas as a kind of a percentage of your grade. Anyway, I'm going to do a video a little bit later on how to submit these things. Again, I'm probably going to find an existing one, more than likely. The reason being is I'm a teacher, and you really need to see it from a student view. Of note, the create task will also be uploaded to the digital portfolio the exact same way. So, is there going to be any other assignments, or is this the Explore task the last one? The Explore task is your last one. Is the due date close to the College Board due date? I'm going to say yes. Somewhere in May, around the 20th or so, is when we'll probably make the due date for us for this Explore task. I want you to go ahead and have them done because I don't want you up against that May 26th deadline. Again, because you not only do you have to complete it, you got to upload it. So you got to give yourself a little bit of time to knock out the upload. Now, it's not hard, but if you were trying to push it as late as possible and you're coming up into like 11:30 range, you might miss it. So that's going to be it for today, guys. Keep an eye out for those upload videos. Go ahead and get started on your Explore task.